All right, guys, what is a relief valve, a pressure relief valve, and how does it work? This schematic right here, that is the symbol of a pressure relief valve in a hydraulic system. Over here, you have a hydraulic pump, you have an electric motor connected to the pump, you have a directional control valve, a pressure gauge, and a cylinder. In a normal position like this, when the pump is pumping fluid, the valve is a normal position. This one, port A, is connected to port B, and it goes back to the reservoir. So there is no pressure. It's just very minimum pressure for the pump to keep on running and pump some fluid through the valve. Now, if you need to move the cylinder over here, you need to create some pressure in order for the cylinder to move. Let's say that you need to do work, and let's say the cylinder is going to move a load. And over here, let's say this is your load, and let's say this is 10,000 pounds. You need to move 10,000 pounds on your load. In order for you to move those 10,000 pounds, you need to create a certain amount of pressure. Depending on the size of the cylinder, if the cylinder is bigger, you need a bigger area, you need lower pressure. A smaller cylinder, you need more pressure, right? Depending on the size of the cylinder. Let's say that in order to move those 10,000 pounds, that you need, let's say that you need 1,000 psi. Let's say you need 1,000 psi over here in order to move this load. And let's say your pressure relief valve setting is set at 1,500 psi. So what happened is that when you shift the valve over here and you say, okay, now it's not going to the reservoir, fluid comes in, goes through the cylinder tries to extend, and it feels the weight, and the weight say, you know what, I weigh 10,000 pounds. And if you don't have enough pressure for you to match my weight, I'm not gonna move. I'm not gonna go anywhere, it says, right? And so at that moment, the system starts building pressure. It builds it by restricting the flow through the relief valve, because the flow cannot go anywhere at that moment. You know, it extends the cylinder, it shifts the valve, the cylinder is extending, the fluid is stopped right here. You know, it's confined fluid. It cannot go anywhere. So you start now creating that pressure. The only other place it could go is through the relief valve back to the reservoir. So the relief valve needs to create that resistance. It needs to create that pressure to say, you know what, the fluid is not coming through here. It needs to go through the other side. And when you create enough pressure, when pressure goes up to 1,000 psi that is needed to move the 10,000 pounds, then the load starts moving. It starts moving and it starts doing work. Now, how does it do that, right? So let's check out my representation of a relief valve. Let's say you have port A on one side over here, you have port B on the other side over here, and then you have port A and port B. What happened is that in port A, you have fluid trying to push a poppet. You have fluid trying to push a poppet through this port A over here. But then the poppet, on the back of the poppet, there is a spring. The spring, if you create tension of that spring, the poppet is not going to move. The poppet is going to stay in place. And say, nope, you're not moving, you're not going anywhere. And the farther that you put the screw in, if you move the knob and you turn it in, you create more tension on that poppet and you create more resistance. If you back up the screw, if you start backing up the knob, then you release some of the tension of that spring, and then the pressure in the system makes it easier to move against that spring, and it can connect port A to port B, and it goes back to the reservoir. And at that moment is how you create the maximum system pressure. So in the schematic over here, when you're moving the load, you meet the load over here, and it says, oh, you know what, I weigh 10,000 pounds, and you have confined fluid, and the fluid say, well, I can't go anywhere. I cannot move the load because it weighs 10,000 pounds. However, though, it cannot move the puppet over here, and it cannot go through the other side. So you still have a confined fluid, and it says pressure raise up, pressure goes up to 1,000 psi. It moves the load, and so you are able to do work. Now, what happened when the cylinder extends all the way out? There's no more, no other place for the fluid to go. You cannot pump more fluid against a cylinder that is full at that moment, right? So at that moment, the cylinder is full, and the only other passage where the fluid can go is going to be through the relief valve. At that moment, then the pressure increases until you get to the setting of the 1500 psi, and at that moment the puppet it moves, it connects port A to port B, and then you have fluid under pressure going through the relief valve, going through port A through port B. You maintain pressure in the system, and the fluid goes back to the reservoir through the relief valve. And that is the purpose of the relief valve. It sets maximum system pressure. Work usually is done below the maximum setting. Sometimes you said it needs 1,000 psi to move the load, and somebody may go and set it to 1,000, 1,001 or so. But that is how a relief valve works. That's the purpose of the relief valve. And if you have any questions, just leave it down in the comments. And thank you very much for your attention.